Okay, these are for notes on interactive notebook pages 60A. We're going to identify when two expressions are equivalent and justify with mathematical reasoning. So one way to prove that two expressions are equivalent is to use substitution. Remember, substitution is when we replace that variable with the same value. So we're going to take a variable, when the variable is in that expression, we're going to replace it with a number, and we're going to see then if the two sides are going to be equal. So we're trying to see if they are going to be equivalent. So values that we should not use include 0, because we know when we multiply by 0, we're going to get 0. By 1, because multiplying by 1 isn't going to always show us, because 1 has that special identity property when we multiply. And also 2, it's a doubling property, so 2 is not the best to use. So we're going to stay away from using 0, 1, or 2 due to their special properties. Properties can also be used to rewrite expressions into another way to show that they are equal or equivalent. So the practice says that some high school students were disagreeing about their Math 1 homework. One student claimed that the difference between 2x and 3 squared was equivalent to 4x squared plus 9. The other student said no, that the difference between 2x and 3 squared is equivalent to 4x squared minus 12x plus 9. Help out these high school students who is correct and explain how you know. So in this problem, we have the problem that is the same for both, and we have the first student that says it's going to be 4x squared plus 9, the second student that says 4x squared minus 12x plus 9. So we're going to take each of those, the original problem, which is 2x minus 3 squared, the first answer of 4x squared plus 9, and then the second answer, 4x squared minus 12x plus 9. And we are going to see by using substitution, let's say that x is 4. We're going to substitute all the x's with a 4 and see which of these, if any of them, are the same. So we're going to say that x is the same for all of them, and it's going to equal 4. So we're going to rewrite this with substitution that 2 times 4 minus 3 squared. This one is going to be 4 times 4 squared plus 9. And then we're going to do 4 times 4 squared minus 12 times 4 plus 9. Now, to practice and make sure that we understand how DESMOS works, I would like you to use DESMOS. Stop the video, use DESMOS, plug in those values, and it should give you the value for each. You can use the blue arrow at the bottom and push enter and keep your answer for those 3 until you come back to see if they're correct. So pause the video, use DESMOS to find the answers, and then turn the video back on to check. The values that you should have gotten, the first one is 25, the second one is 73, and the last one is 25. So that shows us that these two are equal or equivalent. So this problem should have an answer of 25. This is also going to be 25. Now, if we had picked a different number for x, if we had picked a 10 or a 5, these would have been different, but they would have been the same. And then this number would have been greater than either of those two. So that's how we're going to check to see if it works when comparing those expressions. So more expressions given. We have expressions. We don't have the value, but we can decide on the value as long as it's not 0, 1, or 2. So I want you to do the same as we did at the top. Here we're going to say x is 6. Here we're going to say w is 8. And here we're going to say k is 3. Now there is a typo here. Instead of 10x, that should be 10w. So what you're going to do is use substitution. You are going to then put that expression into DESMOS for each, and then you're going to compare. So in between, this is either going to be an equal sign if these two are the equal or equivalent, or a not equal to sign if they're not. So you are comparing the two that are side by side. So I'm going to stop the video. I'm going to ask you to do the same. You are going to substitute for each one of these the value, and that's what you're putting into DESMOS. Now remember, when the coefficient is next to the variable, that does mean multiplication. Okay, so I'm going to stop the video. Okay, looking at the substitution for each, notice as if we use these values, we're going to get the same numbers. Now, we could have used different numbers, but it would have been either they're the same or they're different. So for these first two, using x is 6, I get 608 and 708 and also 708. So that shows that these two expressions, even though they don't look alike, they do have the same value. So they are equivalent. So notice how I've written those with the raised dot. Using DESMOS, when you put in the multiplication symbol, that raised dot appears. Going down, same thing for each of those. Notice these two are going to be equal, so the equal sign. And for the last one, when k is 3, I do not have the same values. I have different values, and so we put a equal sign with a line through it that they're not equal. Okay, quick review on the next page with area and perimeter. I'm going to talk about these, but feel free to stop the video until you get these copied. I've highlighted the keywords, and looking at for each one, notice the first one, to find the area, to find the perimeter of any shape, all you're going to do is add the sides together. Specific when we have a rectangle, which can either be this, where the opposite sides are equal, or a rectangle here where all four sides are equal, also known as a square, they have their own formulas. So because all four sides are the same, a square would be 4 times s. Because a rectangle has opposite sides that are equal, I could have length plus width and then multiply that 2, or I can distribute that 2, but that would give me the perimeter. Area of a rectangle is going to be length times width. Area of a square is going to be side times side, and that's going to be s squared. So, for finding the area of each of these, notice we have 3 sides. And so we're going to add them all together. So we have a plus 4. We're going to add that to 5a plus 12. And then the third side is going to be 10 plus 3a. So the first thing we're going to do is we're going to combine our like terms. So we have 1a, 5a, and 3a. All together, that's going to be a 9a. And then we have the 4, the 12, and the 10. Now, commutative property allows me to go in any order. So if I want to do the 12 and then add that to the 10, that's 22, plus 4 is 26. Okay? Next one. So I have this also, this rectangle. So we're adding all the sides together. So I have 4x for our first side. We're going to add that to 5 plus 2x as my second side. We're going to add that to 8x minus 2 as the third side, and then we're going to add that to x plus 3. So when combining terms and combining that, you can see that my x's, I have 4 plus 2 is 6, plus 1 more is 7, plus 8 more is 15x. Notice with my constants, I have a positive 5, I have a negative 2, and I have a positive 3. So if I add together, the 5 and 3 is 8, and negative 2 is then going to be 6. So it would be 15x plus 6. Okay. Looking below, so see we have the work there. Looking below for the perimeter of a rectangle. If I have length and width, and I know that the length is the same here and the width is the same here, I can multiply 2 times the width plus 2 times the length. Or I could just say y plus 7 plus y plus 7 plus 2y plus 3 plus 2y plus 3. Okay. Final answer should be 6y plus 20. And the last one for the area of the rectangle, remember, area is going to be length times width. So if the width is 8, which is here, that means this has to be the length. It is not 11x. There's only 1x. So it's 1x and the 11. And so we're going to use that with addition, putting those two together. So we're going to multiply the 8 times the x plus 11. Distributive property allows me to get 8x plus 88.